All right, guys. All right. So today we're going to finish up factoring trinomials and polynomials and all that good stuff. And what we're going to do is talk about factoring special cases. All right. Special cases, we're talking about perfect squares, sum of squares, which can't be factored, but still, difference of squares, sum of cubes, and difference of cubes. It's very simple as long as you understand the formulas and know how to derive the formulas. For example, for perfect squares, they're going to give you something of the sort like, for example, 4x squared, and let's put over here plus 9, so that's plus 6x. Okay. What I always like to do here is I like to try to recognize the fact that, hey, wait a second. I have a perfect square here. I have a perfect square here. The square root of 4x squared is 2x. The square root of 9 is 3. Actually, wait. For this to work, this has to become a 12. Sorry about that. 2 times 3 is 6 times 2 is 12. Now I know there's a perfect square. So what do? I take the square root of the first. It's all positive, so plus the square root of the second. And I square that bad boy. That's what's happening in these equations. If you can recognize that the first term is a perfect square, the second term is a perfect square, and the middle is twice the square root of a and b of the first and last terms, then this is a perfect square. So all you do is take the square root of the first plus the square root of the second, and you square it. If there's a minus here in the middle, you take the square root of the first minus the square root of the second, and then you square it. Now, a lot of times, just like me when I was a kid, I didn't really understand this formula 100%. I mean, I kind of knew it, and okay, my teacher put it there, but I didn't really grasp it. It took a while for me to grasp it. So I just want to show you that you can do this using the Cuban method, okay? So I have, come on, man. Oh, Lord. Hold on, let me fix this. Okay, if I've got 4x and 4x, 4 times 9 is 36. What times what is 36 when I add together is positive 12? 6 and 6. Plus 6, plus 6. Artificial factor of 2, artificial factor of 2. I'm going to get 2x plus 3, 2 times, so that'd be squared. So if you want to do it the long way, because this just isn't really sinking in yet, the answer is okay, that's fine. It's a lot quicker once you do recognize it. And trust me, only with practice are you going to recognize it. So, for example, if I gave you 25x squared plus 12x plus 4. Check it out. Is the first one a perfect square?
Yes.
Is the second one a perfect square? Okay. What's the square root of the first one? 5x. What's the square root of the second one? 2. What's 2 times 5? Times 2? 20. Is this a perfect square? No. Does that make sense, guys? Does that help a little bit? Okay. Now, difference of squares is really easy. They're going to literally give you a perfect square minus another perfect square. And that is going to equal the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. For example, 4x squared minus 9. Is 4x squared a perfect square? Is 9 a perfect square? So it's the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Does that make sense? And we're going to have a bunch of examples now in a little bit, but I want to make sure going one by one. Whenever you have the sum of two squares, it's prime. Why do I tell you? Because a lot of people see that and then they get the wrong answer, and I don't want that to happen to you. Okay? So sum of squares, if it says, whatever, x squared plus 81, that doesn't exist. It's not factorable, rather. It exists, but it's not factorable. Difference of cubes and sum of cubes. Okay? These formulas are great only if you can find the a value. So for example, if I have x cubed minus 27. Okay. First thing I always want to do is find my a and my b. And the way I can do that is by finding the cube root of a of the first term and the cube root of the second term. So a equals the cube root of the first term. B equals the cube root of the second term. So in this case, my friends, a equals x and b equals 3. Now it's literally just a memorization. Okay? This was negative. Please notice that when it's negative, you have both pluses. It's weird. And then when this is positive, you have one negative. Okay, please be careful with that. So now I have my a and my b. It's a minus, it's a difference of cubes. So it's going to be a minus b times a squared minus ab plus b squared. And one thing for sure, you will never be able to factor that trinomial. So don't try, don't waste your time on that. Okay? Does that make sense, guys? I'm going to take that as a yes. Okay. Okay, I got 4 minutes left, so I'm going to have to kind of speed through these, but luckily that's why we have a video. All right. I can just recognize these, okay? So it's kind of not fair. I've been doing this for a long time. But x squared is a perfect square, 16 is a perfect square. X times 4 is 4x times 2 is 8x, so this is just going to be x plus 4 squared. If you didn't see that, you could do the old way, bro. 4, that's still going to be x plus 4 squared. You feel me, guys? Okay. Here, that's a perfect square, and they're being subtracted. It's a difference of squares. So it's going to be square root of the first plus square root of the second times square root of the first minus square root of the second. Done. Okay. Let's continue here. 3. Looks tough, but that's why you need to learn how to recognize these. That's a perfect square, which is 6x. That's a perfect square, which is 5. What's 5 times 6? Times 2? 60. So does this work? Yes, it does work. Guys, yeah, because what's a negative times a negative? That's a positive, and then you'll have a negative here in the middle. So this is going to be square root of the first minus square root of the second. That's a perfect square. You guys see that? It's a lot easier than going 36 times 25, and then what times what equals that, but when added together is 60, right? It's a lot easier. This is a perfect cube. Cube root of 8y cubed equals a, which is going to equal 2y. Cube root of 27 equals the b term, which in this case is going to equal 3. Please do not find the cube root of negative 27. No. Find the cube root of the ay cubed and then of just the positive 27. This negative just is indicating whether it's a difference of cubes or a sum of cubes, okay? So now this is a difference of cubes. It's going to be a minus b times b squared minus a times b plus b squared. We good so far? I'll take that as a yes. Okay. Here, is that a perfect square? Yes, that comes out as x. Is that a perfect square? Yes, that's 10. What's 10 times x? Times 2? So is this going to work? Absolutely. This is going to be x minus 10 squared. Why did you put a minus, Moro? Because there's a minus there, and that comes from the formula. This one, let's just knock these out real quick. Perfect square, difference of squares, y plus 11 times y minus 11. Yes, either formula doesn't work. Now here, can I factor out a GCF? Do it. So then I got x squared minus 1, so this is going to be x plus 1 times x minus 1. You guys seeing this? Promise? Yeah? Let's look at number 10 real quick. I know I'm jumping around, but I want to just hit as many as I can. Perfect square, that's 2y. Perfect square, that's 9. What's 2 times 9? Times 2. So this works. Square root of the first plus square root of the second squared. Okay? Let's do this bad boy down here, 12. The cube root, believe it or not, of negative 125x cubed, which is my a term, is just negative 5x. And the cube root, believe it or not, of 729. Now remember, I use this negative because it was attached to the 125, but I do not use this negative for the 729. So the cube root of 729 is going to be 9, believe it or not. In 1 second, guys. So a minus b times a squared. This is a minus, so it's plus. Right? Actually, that should be plus. Whenever you have a minus, it's a plus. Plus 45x plus 81. Thank you very much. Have a great day. God bless you. Bye-bye. Study, study, study. Oh, wait. Your homework. Don't leave yet.